Okay, hello everyone. Can everyone on Zoom and in person hear me? Like if you're on Zoom, can you just like react with a thumbs up or something? If you can hear me. Amazing. Okay, cool. So today we're covering authentication, and authentication is super useful because probably every app that you use on a daily basis has a login system. So yeah, today we'll be covering it. And before we talk about the content, just a couple of announcements. PA6 deployment is due Saturday at 11:59. And if you didn't see my ed post, like make sure you use your personal Gmail, not your Cornell EDU, because we're still trying to figure that out. And then sign up for a free trial using that. And then because we extended the deadline to the late submission deadline, there will be no late submissions allowed for this one. So yeah, make sure you turn it in by Saturday. And also, let me see, this seems to be a question. I'll answer it later. But yeah, PA6 is the last programming assignment. So after this, there's no more assignments for the rest of the semester. So yeah, that'll be fun. Congrats on making this far. Let's see. Where's my mouse? Okay. Oh, okay. Okay, so one more thing before we dive into the content is hack challenge. So this is, I can't see my mouse when I like, I don't know how to move this. Okay, cool. So hack challenge is coming up next week, and this is a 2-week hackathon for students in this class and also from other app dev courses, so like iOS and Android. And this is required because this is basically our version of a final exam / project. And it's supposed to be really fun. You can win a lot of different prizes and different awards, and the prizes are like pretty good. So, and also this hack challenge is a really good way for you to add a project to your resume for recruiting. When I like took this course, I think my like project from hack challenge is still on my resume. So yeah. And then you're allowed to like, because you're working with developers from other courses, you're able to like build a full stack app with an iOS or like an Android front end. And yeah, that's really cool because you get to see how each sort of role functions and you get to collaborate with them to build something. So yeah, hack challenge was very fun. And the timeline for this is kickoff is next Monday. The location is still being like determined, but we'll let y'all know. And basically, you have team matching on like a forum for it, and it's due Friday. This Friday, yeah, it's due this Friday, and it's mandatory. But if you are looking for devs from like other classes, a really good way to do that is going to the team matching mixer this Friday. 4:30 to 6:30 p.m. and up to 1:42. And yeah, if you have any questions, feel free to contact Shingo and I. But more info will be released soon. All the forums should be released by Wednesday. This is a preview of what's going to happen over the next few weeks. With that being said, today, Shingo and I are going to take a break from lecturing, and we're going to have guest lectures. And so we have Jessica over here and Caduce, and they're both sophomores on Backend, and they're very good devs. So yeah, we should be honored to be learning from them. But yeah, I'll hand it off to Jessica for. Okay, I'll hand it off to Caduce for the authentication question.
Hello, my name is Caduce, and we will be learning about HTTP communication. So in review, HTTP is used to communicate between clients and servers. They communicate between each other using requests. And the request contains URLs, query parameters, methods, and bodies. The responses from these requests from the server to the client will also contain a body and a response code, like failure or success.
You're not going to build that into a word.
Could you repeat that? Sorry. Hello?
I think they were just
Yeah.
wanting me to.
So application needs that we want with these requests are, we want to incorporate users so that we can have like social media accounts, maybe banking accounts, things like that. And we want to be able to have permissions so that they can only interact with the information that they are supposed to, right? So we need to find a way to have these users authenticate themselves. And what do we use? How do we verify these requests, like that they send? Well, here's an example request first, right? It has a title, a link, a user. We could just assume that the person who sent this is Alicia, like in the user, but it could have been anyone. So we have to find some way to actually verify that that user is Alicia. And we do that using authentication. Ooh. So an overview on authentication. To authenticate a request, we would normally include extra information to verify the user's identity. Yeah. We validate the server request based on these provided credentials. And then we will create these specific permissions for the user based on the identity of the user. So how do we do that? Well, one example that's pretty common in most settings is registration and login. So here's your typical registration form. You use an email and a password, right? You would type in your email, type in your password, and you click sign up. And after that, the credentials get sent to a database and they're encrypted and stored. After that, credentials are sent to the database and they will be authenticated based on whether a pair exists or not in the database. These requests will have some metadata included in them. Some examples of headers in the metadata are content types, which is the type of the body. These can be like application/JSON, which contains JSON data, or text/plain, which is like plain text. You can also have a cookie header, which will be state data of the user that is the browser contains. So it'll be, you can store things like username, password, location, language, things like that. You can also hold the user agent, which is the user's browser plus software information. You can also have an authorization, which has specific credentials that we use to authenticate. And here's an example of a request header. It's kind of small on the screen, but as you can see, there's the cookie, which is a bunch of data, and some other headers that we might not talk about today. So for the authorization header, we have 3 schemes of sending requests that we would put in this header to authenticate a user. These 3 are HTTP basic, HTTP session, and HTTP token. And Jessica will be talking about HTTP basic.
Okay, starting off with HTTP basic. It's very basic. It's the simplest one, not that secure, because basically starting off, it would first start with encoding the username and password. Note the difference that we're using the word encode here. Encoding is not the same as encrypting. It's not as secure and it's a lot easier to then decode. This information is then cached on the front end, and then you send the encoded credential with every request to the server. So essentially, your encoded username and password is sent with every request, which isn't that secure. And then lastly, the server validates the encoded credentials. So like looking at this GET request, the part we want to look at, the authorization line, the header is basic, representing the base64 encoding of the username and password. And so essentially what that ZM, 9V, et cetera, at the end, that represents the encoded username and password. The entire point of encoding is to basically condense that information into something more simple to then be stored. So this is a registration process. So the information for registration is sent from the client to the server. The server then creates the new user and then returns the response. and success, we created a new user. And then later on, when the client wants to log in or do anything at a later point in time, they then send the encoded credentials to the server. They then decode the credentials and they validate the password. Basically, that means that they split up the decoded credentials into the username and password, and then checks that the password matches the given username, and then they return the given response. So success, you then get data. So the benefits of HTTP basic is that it's a lot more simple. You use encoding instead of encrypting, so it's a lot easier to decode on the back end. And essentially, it can be used on any front end as well, so users do not have to rely on any specific front end. And essentially, any client will be able to use a service since it's so much simpler. Yeah. The drawbacks, I think the main drawback is just security in all aspects. So as I said earlier, the username and password is exposed in each request. So anybody is able to get access to any form of traffic. They'd be able to somehow get their encoded username and password, decode it, and then bam, everything's exposed. Your username and password is stored on the front end. So essentially, yes, the front end, that's in your phone, but say, for example, your phone has a virus and then someone hacks your phone, your username and password again exposed again. And again, you're not really in control of where your username and password is. Since it's on the front end, you're not in control of when it's deleted. So it could be deleted maybe when the app is closed or removed on the browser, et cetera. But again, you're not in control of the protection or security of your username and password. And then lastly, the security of a request is dependent on HTTPS. So if the server, if HTTPS is not used, the S stands, it's an extra layer of security. If you don't have that extra layer of security, then you're very vulnerable to any attacks of your username and password. And now Kidus will be talking about HTTPS sessions.
All right, so talk about HTTP basic. Now we'll talk about a second scheme, HTTP sessions. So HTTP sessions are pretty similar in how we start them as basic. As in, first of all, we send the username and password to the server like before. The server will generate the credentials on, wait, let me step back. So we're logging in, right? Or creating a user. We send the username and password to the server. The server creates the credentials like before, but this time the server will also create a session and an associated cookie. So this cookie will store the session data and store it in the browser. Unlike how we did it in basic, where in basic we stored the username and password in the browser, just kind of slightly encoded. This way is slightly more secure. And every time we want to authenticate the user on any request, we will just send this cookie to the server, similar to how we would do in basic, except the different. Yeah. So here we have the cookie. You can see it has a lot of user state data, but circled in green here is a session ID, which points towards the user and is user data. I mean the user's authentication. So on registration, we send the username and password to the server. The server then creates a new user, stores in a database, and then creates a new session, because after you register an account, you typically want to be logged in afterwards. So it'll create a session for you and return the cookie with that session, which will essentially log you in after you register. Then the cookie is sent back to your client, back to the client and stored in their browser. So now they'll be authenticated in the future. Now, if you send a request that is you want to go to your main homepage on Twitter or something, you have to be authenticated. So it'll send your cookie to the backend again, the server, and it will parse the session code stored in the cookie. And if it is validated, it will return a success response or a failure response. And then from there, you'll either be allowed into the page or kicked out. Also, the session has a unique thing where it can be expired. So if you stay logged in for too long, eventually it will expire and you will not be able to authenticate and return a failure response. As you can see, failure expired. So now if you want to re-log in, not register, just log in again. It'll take your username and password from the client to the server, validate them, check if they're in a database, like if they're correct. And then it'll create a new session, put them in a cookie, and then return the cookie back to the client, and now they're authenticated. So the benefits of sessions over basic or any other scheme that you don't have to continually send over credentials. Since they're stored in the cookie, you can just send the cookie over, and it'll check the cookie and then let you in. And also you have the expiration time, which is actually quite modifiable. You can tune it to whatever you want. So you can tune it to be more convenient for the user by like not making it very strict, or you can make it like pretty strict and then make it quite secure in case someone like finds your computer open and just logs. Someone like finds your computer open and just goes into your account. However, some drawbacks include like the fact that sessions are kind of big and they kind of take a lot of space on the cache, and cache memory on browsers is quite small. So they take a lot more space than just basic, since basic is literally just a string of username, password, hashed, and basic default. And also, if the client deletes their cookies by like deleting history or something like that, you have to relog in, which is a drawback that exists. And yeah, that is essentially HTTP basic. And now Jessica will talk about HTTP token.
Okay, so tokens. So HTTP tokens are pretty similar to sessions, but there are a few differences. Start off, send a username and password to the server. The server validates these credentials. And then the main difference here, server generates and returns a unique access token. The cache access token is stored on the front end, and then the access token is sent on every request to identify the validated user. So here we have another GET request. And then the main difference here again is like authorization. There's a bearer, and then this is our access token. This token, it's like a long string of letters. This is the encrypted username and password. So it's not as easy to like essentially hack, quote unquote. And then another difference between tokens and sessions, they're stored in a database in the backend. So here we have like a table for the token. So each token will have its own ID. And then the token also has the user ID. So every user is linked to its own token. And then the access token is then given there. Another thing about tokens, kind of similar to sessions, is that they also expire. So you design access tokens to expire after a given period of time. So that's a great thing about tokens, is that if there's accidental exposure, it's not the end of the world. It'll expire and then you'll have to give a new one. Users request new access token after the existing ones expire, and then you're able to accomplish that using a new refresh token. And this new refresh token is a one-time token to then generate new tokens for the user. So here we have our table token. And again, as I said earlier, you have the ID of the token, the user corresponding to that token, the access token itself, the date that it would expire at, and then the refresh tokens, you're able to generate new tokens in the future. So here's an example. You're registering a new user. The client sends information to the server, and then you create the new user. You create the new tokens being the access token itself and the corresponding refresh token, and then you would return these tokens. And so the tokens are then sent back to the client and stored in the cache. And then another time when they want to like send a request, they would send the access token, validate the token, and then execute the operation. So basically do whatever the user had intended to do, and then return a response. In a case where there's an invalid token, they would then return a response to the client that the token has then expired. The client would then send the refresh token, which would then validate the server would then validate this given new refresh token. They would then create new tokens, both a new access token and the new refresh tokens, and then return all the new tokens. Okay, benefits, yes. The user credentials are set less frequently because of recess tokens. So essentially, like the username and password encryption is only exposed, it's exposed fewer times since you're not dealing with like that encrypted information, you're just dealing with the tokens. And then you're able to like tune the expiration times between user convenience and security. So you're able to like set how long the tokens until the tokens expire essentially. And essentially, since they're stored in a database and not in memory, like random access memory, it's more scalable than session cookies.
Okay, so before we move on to just a summary of today's lecture and demo, I want a moment to thank these two for guest lecturing today. This is the first semester we're doing guest lectures, and it's because of people like Jessica and Kidus that we're able to pass on the knowledge for future generations of people that come to Cornell and want to learn backend. So yeah, round of applause for these two, please. Thank you for guest lecturing today. So yeah, let's just quickly summarize what we went over, and then Kate will get into demo. So there's three types of schemes for authentication. The first one is HTTP basic. The reason why that's bad is because we send the username and password upon every request. Good. Second type, HTTP session. Sessions are also great. They don't have as much glaring disadvantages as HTTP basic. The only issue with that is that when you log in, it returns a cookie that is then cached, or i.e. stored in the front end. And the cookie is sent along with every request. And the cookie contains information that is used to validate that, hey, this is the correct user that I'm getting the request from. But the reason why it's not as optimal as HTTP token, which is what we're going to be demoing, is because a cookie is generally pretty large. It contains a lot of information that is sometimes redundant. And so HTTP token is our solution to that. So what token is that every time you make a request, you're sending in this token, which is this uniquely generated session token, which is like a bunch of strings, like you saw in the database earlier. Oops. I did not need to do that. Like you saw in the, just go to the slide directly. Table earlier, right? So Kate and I have an associated token. So if let's say Kate logs in and is trying to access a resource, then when she sends along with her request, if she sends a string EF3A whatever, then we know that Kate is in fact the one who is actually sending this request. So that's why tokens are efficient, because all you need to do is send a string that is randomly generated, right? So no one can guess it, and you'll know that, hey, this is Kate, or hey, this is Shungo. And if that's not the case, you can tell them, hey, you're not logged in, go away. So yeah, that's how authentication works. Any questions in Zoom or in person? We're good? Awesome. Okay. Yeah.
Yeah, I just want a quick question for you. Like, it seems like token is like session, but stored in the backend.
So yeah, that's correct.
Why would you ever use a session over a token?
Yeah, so session, right? Again, the thing is that you're going to be sending cookies, right? And cookies contain a lot of data that you wouldn't have in just a string, which is the token. So this can be, if I can find the slide. Yeah, so if you look at this slide, you can see that it has a bunch of random stuff. And the gist is that along with the session token, it contains a lot of other metadata. So for example, if let's say you're on Amazon, for example, right? And let's say you're shopping things. Whenever you go to like a different part of Amazon, you don't want your shopping cart to clear, right? You want that data to be saved. So saving sessions, you can think of it as like saving things along with the session token, i.e. like the shopping cart that you have on Amazon. So that's one example of when you would use a cookie over a session token. Does that make sense? Yeah. Are we good other than that? Okay.
Okay, hello everyone. Okay, so yeah, we'll be doing demo now, but before we like start coding, I'll just like demonstrate first like the finished result, so you have like an idea of how everything works. So let's see. Let me my starter code. Okay, I think it's still running. But so basically, let's say I wanted to register my account. Okay, so I'm just gonna say my email is kate@cornell.edu, and I'll pass in the password. So when I create a new account, basically we have a session token, a session expiration, and an update token that's returned to us. So the session token is what we talked about in lecture. It's sort of like the access token that uniquely identifies us. So in case we want to like, I don't know, like pass in some secret data, we have to first pass in the session token to verify like it's us. And then the session expiration is just when this session token expires. So you'll see in the code how long this takes, but I think it's like a day or something from like when you create it. And then this update token is just another type of token, but it's like what we use to like generate a new token. So an update token is like very useful because
It's gonna mind me fucking this stuff. I'm fucking looking over. I'll play my best. It's a big move for me. Yeah.
I feel like that person is supposed to be muted. So I'll mute them. If they have a question, feel free to ask, but I don't think that was a question. Yeah, so an update token is basically what we use to update the session token. So this is different from the session token. This is what we use when we want to update the session token. And we need an update token because the session like stuff is passed in through the header, and that's not very like safe because anyone can really intercept that. So if we want to kick someone out, we can just use an update token and then like create a new one. But yeah, that's basically what is returned. And then when we want to like get some secret data or something, we can pass in the authorization and then like the token. But we'll like demonstrate that all later because I'll be coding it, but that's how it works. But before we start, make sure you like go to the backend course textbook. And I realize this is all really small, so let me zoom in. But yeah, make sure you go to the course textbook and download the starter code for demo 7 or lecture 7, and make sure you like refresh it because like we updated some things and sometimes Gitbook like caches your stuff. So make sure to refresh it so you get the newest like file. But once you like download that and unzip it, let me see what's here. Okay, I think this is it. So this is the starter code you'll get, and you'll see we have, oh my God, sorry. So you see we'll have like our usual app.py, db.py, and then we have something called a user's DAO. So a DAO is basically a data access object. And this is just, you'll see right here, it's a helper file, and it just contains different functions. And this sort of just abstracts some functions away from our like database, and it makes it easier to call. So like we can call get user by email really easily in our app.py now. And yeah, it just sort of abstracts different functions so that it's like easier to call. But yeah, that's what a data access object is, slash a DAO. But yeah, so let me increase the size of this. Is this a good size for everyone? Okay, cool. So the first thing we're going to do is open our terminal, and then we're going to get a virtual environment. So make sure like when you open your terminal, like you're not already in a virtual environment, because the thing about this demo is that we're actually like installing new packages. So make sure you create a new one and like install the packages because there's some new stuff there. So once you create a virtual environment, remember to activate it. And then do pip3 install. Oh my God. Let's see. Okay, so I had this issue earlier. I'm not really sure why the requirements.txt doesn't work, but if it works for you, great. If it doesn't, try just like installing like each of these things separately. So first install like pip3, install decrypt, which is like something we use to encrypt and decrypt passwords. It's basically a package for that. But somehow, like, I don't know really why it doesn't work in the requirements file, but just do that in your virtual environment and then do pip3 install last. And that should be all the packages you really need if the requirements.txt didn't work for you. So yeah, I'll just, did everyone like catch that? Where is everyone okay with their requirements.txt right now? Okay, cool. Might just be my laptop, but let me confirm. Okay, that looks good. Okay, so now we have all our packages. So the first thing we want to do is I'm just going to explain what sort of we have right now in our starter code. So you'll see in our db.py, everything is already created for us. So we have our user model. And one thing I want to emphasize is we have our session information right here. Usually you should not do this because like, let's say you're on like Instagram, you can have like multiple sessions on multiple devices, right? So you can have like a session on your phone, a session on like your iPad, a session on like your computer if you like logged into Instagram from each of these devices. So you'd have like multiple sessions, and yeah, that would cause a relationship between like your sessions and your users. But for the sake of like simplicity in our demo, we just put it all in your user, so you only have like one session. But yeah, that's usually how you're supposed to do it. This is just for simplicity purposes. And then yeah, so here in our user, we just have a user, or I mean, email and a password. And the password digest, like once we create a user, basically this bcrypt thing, this whole like long thing here, this encodes the password to be stored in our database. And this is really important because we don't want our passwords just to like hang out in our database. Like if anyone intercepts our database, they're just going to see all our passwords. So in the case that someone does like see our database, we want to like protect our data. And so we encrypt it using like this function, and bcrypt just the package that does that. And then we use it in the format like UTF-8. So that's just like the format we're hashing our password in. And then it creates like a salt. And then that salt's like just a unique representation of your password. And yeah, that's basically what bcrypt and this whole line does. But essentially just know that it stores our passwords in a safer way so that it's not just like out there in our database. And then this is just a function that generates like our session token, expiration, and update token. And then, yeah, this is just generating hash tokens. And then renew session, yeah, this just creates a new session token. You can probably read through all of this, the documentation. But yeah, this here right here is where we define like when we want to set our expiration date to. So in lecture, we said this was very flexible. So like I can easily change this to like 10 days or like half an hour, but yeah. And then this is just some other things that verify the password, session token, and update token. And this is just making sure this is equal and it's not expired. And this is just making sure it's equal. And then this one is taking bcrypt, and then we take like the encoded password and then the password that's stored in our database. And then we just like make sure that's like matched. But because we don't really know what's happening, bcrypt tells us or does it for us. But yeah, that just verifies it. Does it kind of make sense what's happening in db.py? Okay, cool. So yeah, that's just what's happening here. And then the first thing we're going to do is we're going to actually create a user. So before we create a user in our data access object or our DAO file, we're going to see if we actually have a user already with this email. So this is going to be called optional user. And I forgot to say that, yeah, over here, this is just like different get commands. And then this is just like very similar to what we did like with our assignment, where we just filter a user by our ID, but now we're just getting users by different like unique identifiers. So our email, like only one email should be associated with one account. And then like our session token is unique and our update token is unique. So this is just like different get user commands, and it's already written for us. So we're just gonna call it. But yeah, when we create a user, the first thing we're gonna do is get user by email and see if this user is already like in our database. So it's called optional user because optional is actually type of like a data type. And it's like kind of just like none were an int, none were a string, none were this. So here it's like none were a user. And yeah, so once we create an optional user, we're going to see if our optional user exists. And if optional user is none, we're going to return a tuple. So I think tuples are not covered in 2110, but it's covered in 3110. But tuple is just like a pair. We can return like, you know, two things. So we're going to return a false, and we're going to return the actual user. And then otherwise, that means our user doesn't exist. So we're going to actually create our user now. And to do this, we're just going to like create a new instance of our user table. So this is, again, what we did in our assignment. You just like define a new using the parameters we pass in, and return true user. But yeah, that's basically our create user function and our DAO. And we're going to call create user in our app.py. Yeah, let me make sure I'm good on time here. Okay, cool. So yeah, so we're going to call create user when we register an account. So as we saw in Postman, when we registered an account, we had to use email and password. So that's the sort of data values we're expecting from our body. So this is just like a typical like, I guess post request. We just take the request body and then we like parse the information. So is this like a good speed for everyone? Like, has everyone caught on to stuff? Okay, cool. Body get password. And so now we just got the information from the request, and we want to make sure like they exist. So if they don't, we're going to return a failure response. And we'll just say like invalid, we're missing user email. And then otherwise, we're going to call the create user function in our DAO. So to do this, we're just going to call like, we need to set two variables first because we returned a tuple here. So we're just going to say was successful and the actual user, because we should be returning the user no matter what. So we're just going to call create user from our DAO, and then we have to do users DAO. So I'm getting a warning, but this is because I haven't imported my users DAO yet. So I need to, on the top of my file, just import users DAO, and this just makes sure that like all the functions in users DAO, like users DAO, is accessible in the app.py. So yeah, this is very similar to just like importing your DB, and yeah, we can just like access the functions in our DB file. Cool. So yeah, so after we call create user, we have two sort of things: if it was successful and the actual user. So we're just going to check if it was successful or not, and if it wasn't, we're just going to return a failure response. And we're just going to say user already exists, because that's the only instance when we return false. And if it was, we're just going to return a success response. Okay. We're just going to pass in, I think it's just the, oh, yeah, it's this stuff right here. So we're going to pass in the session token, expiration, and update token. So to do that, we're going to create our body. So first thing we want is our session token. So we're just going to get the user and get the session token. And we're able to do this because we have, like, it's defined in our database at like a field. So we can just do that. And we have our session expiration. And that's also just another field. And this is a date-time object. And you can see here it's of a date-time type. So we want to parse this as a string, or convert it to a string. And then the last thing we want is an update token. And oops. And then we're just going to return user update token. And then this is a 201 request because we're registering a new account. But yeah, that's just how we create a new user. We're registering an account. So again, we're getting the information from the client. We check if it's valid. We call create user in our DAO, which actually creates the user. And then when we initialize, like when we create this object, remember in our db.py, the renew session actually generates all the session information for us. And then back in our app.py, we can just call the different fields and get it when we return a response. Does that kind of make sense to everyone? Cool. So let me stop this. Let's run our server now. So let's do Python 3 app.py. Cool. So let's make sure everything works. So I'm going to go to our workspace and create a new collection. And again, here we create a new collection in Postman. So it's like neat and you know what's happening. And we're going to create a request, and this is just registering account. And this is a post request and HTTP 5,000. Oh, sorry. And then in our body, we're returning we're passing in raw JSON, and then we need email, which is zero. I'll just say it's let's say hello world. Funny. Okay, so let's send this. Request has no actual body. Request body. I think I just like, oh, request.data. My bad. So make sure you change that to data. And oh, user already exists. Oh, let me just create it under a new account. I'll say like SN684. Oh, it's because like the database was already created. Let me just delete it and do it again. So this creates a new database, and we're just going to do this. Where is this? Oh, wait. I forgot it into the database. I'll just say like 5. Oh my god. Let me see. Okay. Okay, sorry, I don't know why my code isn't working. Let me see. If not, was successful. Return failure response. Okay. Since we only have like 4 minutes left, I'll just get started with Kahoot and I'll figure out what's wrong my next time. Sorry about that. Yeah. Okay, so yeah, we'll just move on to Kahoot. And okay. Oh. But yeah, sorry.